Hi, okay, so this is a revision video for the whole of topic 1, which is force and motion. So this is going to be a fairly lengthy video. Obviously you've got a chance to pause this and as you're going through to look back through your notes and question papers and stuff like that. So this is just a quick reminder. Okay, we started off by reminding you of probably the first physics formula that you ever came across. Speed is distance divided by time. We will normally measure the distance in meters, the time in seconds, so the speed is in meters per second. However, quite often in physics we use kilometers and hours, so the speed is in kilometers per hour. We've just looked at this. You are expected to be able to convert units. So just remember that a meter is 100 centimeters, so 1 centimeter is 100th of a meter. So look very carefully at questions, make sure you're using the correct units. Okay, so we need to be able to rearrange this formula. So we need to be able to calculate a distance if we're given the speed and the time. So if you look at your formula there, if I was to multiply both sides by time, obviously divide by time, multiply by time, that would disappear. On the other side we get times time, so we end up with distance is speed times time. If we want to know the time and we know the speed and the distance, if we rearrange that, so this is cross multiplication, time is distance over speed. If mathematics is still an issue for you, you need to learn how to do this. It's not going to go away. But at the moment, we can use this formula triangle. So remember, you cover up what you want to calculate. So if you cover up the distance, it's speed times time. If you cover up the time, it's distance over speed, or distance divided by speed. If you cover up the speed, it's distance divided by time. So you need to learn that. Okay, just a reminder then again about units. If you're using meters and seconds and meters per second, you can't mix meters and kilometers. You've got to decide on one or the other. Most questions will be fairly obvious. Okay, we then looked at distance time graphs. So be careful here. We looked at distance time graphs. We looked at speed time graphs. Similar, but not the same thing. Okay, so for something traveling at constant speed, so every second it moves the same distance, we have this straight line. And the gradient of that line, so the rise divided by the run, gives us the speed. And that makes sense, doesn't it? Because the rise is the distance, the run is the time. So the speed is the distance divided by time. Easy to remember. And obviously, if it's going faster, it's going to be a steeper gradient. It's going to travel a bigger distance in less time. And if it's slower, it's going to be a shallow gradient. In English, we say steep, shallow. And obviously it's going faster, the gradient is going to be increasing, so we're going to have a curve. Here's an example. So a car accelerating, so the distance time graph is a curve, and of course when it hits a wall, it's not moving, so the distance stays the same. Okay, we then looked at speed time graphs. So again, be careful, these are not the same. They look the same, they're not the same. So obviously if something's not moving, the speed is 0. So even as time, after 1 second, after 2 seconds, if the speed is 0, we hit that flat line. Okay, so in a speed time graph, if the speed is constant, if the speed is not changing, so this is now a flat line. So if you remember in a distance time graph, constant speed was a straight upward slope. So in a speed time graph, it's a horizontal line. Obviously, if it's a faster constant speed, it's going to be a higher line. If it's slower, it's going to be lower. If it's going faster, now this is a special case of what we call constant acceleration. Every second, the speed is increasing by the same amount. So, you know, when you drop something, the acceleration due to gravity is 10 meters per second squared. Every second, the speed increases by 10 meters per second. And to find the acceleration, lo and behold, yes, it's the gradient of this graph. So the acceleration is the change in speed, that's the rise, divided by the run, the time taken. And that's where this formula comes from. A equals v minus u over t. So v is the final speed, u is the initial speed. So v minus u is the change in speed, so that's the rise, t is the time taken. Okay, you're going to have to remember this. You won't come across why this is until you do calculus in year 12. But the area under this gives the distance travelled. So in this case, it's a triangle. So if we were to find the area of that triangle, it would tell us the distance travelled. It's not always a triangle. In this case, it's a triangle. Here's an example. So a dog falling from a tall building. We're assuming there's no air resistance. So the dog just gets faster and faster and faster. Yeah, in fact, every second speed increases by 10 meters per second. That's the acceleration due to gravity. So the area under this graph, obviously when the dog hits the ground, its speed goes to 0. The area under this graph is the distance travelled by the dog, which of course in this case is the height of the building. Okay, we learnt that velocity is just speed and direction. Yeah, so we said that velocity is a vector because it has a size. We normally call that a magnitude, just like speed, but it also has a direction. So I could say my speed is 5 meters per second. My velocity is 5 meters per second this way, or whichever way we're moving. Okay? The opposite of a vector is a scalar. You'll do this in mathematics. So a scalar is a quantity that doesn't have direction, like speed, like mass. You know, my mass is 90 kilograms, it doesn't have a direction. Okay, we then looked at something more complicated. We looked at something called the equations of motion. So these are formulas that use lots of letters. U is the initial velocity, that's the starting velocity. Often it's 0, it doesn't have to be 0 though. V is the final velocity, so that's at the end of the motion you're thinking about. S is displacement. Now that's the velocity. That's the vector equivalent of distance. So basically it's the distance and direction. It's confusing. They use the symbol S for that, for distance. You're just going to have to remember that. A obviously is acceleration, T is time. We call them the SUVAT equations sometimes because of SUVAT. Okay, these are them. Oh, sorry, I've made a mistake this thing. You only are going to use 2 of them. So you're going to use this one, V equals U plus AT. That's just a rearrangement of A equals V minus U over T. And we're going to use this one on the bottom. V squared equals U squared plus 2AS. You're not going to use the ones in the middle. You'll learn that in year 12 when you do A-level or IB physics. Okay, now just remember in this, all the quantities, velocity, acceleration, displacement, or the distance is a vector, has a direction. Time is not. We could get into lots of philosophical questions about time and direction. Okay, so here's an example. Mr. Porter, he's driving his car when suddenly the engine stops working. He is travelling at 10 meters per second, so that's going to be my initial speed. And his acceleration is minus 2 meters per second, obviously. So if the engine stops working, I'm going to slow down. My acceleration will be a negative number. 30 meters ahead of him, Madeleine, do you remember Madeleine? She was with us for a short time. Stepped into the road. Will Mr. Porter hit Madeleine? So, always the same in physics questions. First, we'll write down what the question is telling us. So the question is telling us at the start of this question, my speed, my initial velocity is 10 meters per second. I'm going to stop, so my final velocity will be 0 meters per second. I know my acceleration is minus 2 meters per second. I want to find how far will I travel, i.e., will I travel more than 30 meters when I hit Madeleine, or my distance will be less than that, I will miss her. Okay, next, again, all physics questions are the same. We write the equation down we're going to use. Well, in this case, we know V, we know U, we know A, we want to find out S. We've got one unknown, so we're going to use V squared equals U squared plus 2S. We then put the numbers in. Okay, so we know V is 0, we know the initial speed is 10, or the initial velocity is 10, 2 times A, well, we've been told that the acceleration is minus 2, times S. We don't know what S is. We don't know what the displacement or the distance is. Okay, then we just need to do some mathematics. 0 squared, 0 times 0 is 0. 10 squared, 10 times 10 is 100. Okay, 2 times minus 2 is minus 4. Okay, so it's going to be 100 minus 4s. I'm going to add 4s to both sides. So I've added 4s on this side, so there's a 4s there. I've got minus 4s. If I add 4s to that, that will disappear. Minus 4s plus 4s is 0. So we end up with this. 4s equals 100. If I divide both sides by 4, this will disappear. 100 divided by 4 is 25. So the car does not hit Madeleine. The car stops after 25 meters. If you remember from the question, Madeleine was 30 meters ahead of Mr. Porter. Okay, slightly harder one this time. A ball is thrown upwards with a velocity of 24 meters per second. That's a pretty good throw. What is the maximum height reached by the ball? So if I throw a ball very fast, 24 meters per second up in the air, how high will it go? Okay, well, I know that the initial speed is 24. Now, the ball is going to accelerate towards the Earth in the opposite direction. So it's going to slow down, i.e. the acceleration is minus 10 meters per second squared. Now, when it gets to its maximum height, it's going to stop, isn't it? It gets slower and slower and slower until it stops. So the final speed is 0. And I want to find how far does it travel, i.e. how high is the throw. Okay, so same thing again. We write down our equation, v squared equals u squared equals plus 2as. We put the numbers in. So the final speed when it reaches the maximum height is 0. The initial speed was 24. 24 times 24, 24 squared is 576. Plus 2 times a, well we said a was minus 10 times s. Okay, so 2 times minus 10 is minus 20. So it's 0 equals 576 minus 20s. By the way, if algebra is a problem, you know, this is something you can work on over the summer. Get a year 8 maths book, borrow one from Miss Garforth, and do some of the algebra exercises in there. Because, again, this is something that's not going to go away. It's, obviously, we do this a lot in maths, we do a lot in physics. If you do economics or business or even chemistry, this rearranging equations using algebra is something you're going to have to learn to do. So please try and do that. So get a year 8 maths book. Year 8, learn how to do this. Okay, so carrying on there. So if I add 20s to both sides, minus 20s will disappear, 20s appears over here. If I divide both sides by 20, that 20 disappears. 576 divided by 20 is 28.8. The other way of thinking about that when I'm rearranging formulas is if I take this minus 20s on this side becomes plus 20s on this side. Okay, if I multiply by 20 on this side, if I move the 20 on this side, it's divided by 20. That's another way of thinking of moving the algebra around. Okay, we then moved on to forces. So this is going back to year 7. In fact, it's year 5, I think, this year. So a force is a push or a pull. Okay, it is measured in newtons. Okay, force is a vector in the same way that velocity is a vector, has a direction. Forces have a direction. And so we can represent them with arrows quite nicely. We'll see in a moment. Okay, lots of different types of forces. So there are some examples of forces there. One particular force you need to know about is friction. So friction will oppose the motion of something. So it's always in the opposite direction of the motion. And you need to know a little bit about how we add forces here. So I've put a tug of war on there because obviously tug of war is a good example of us adding forces. So obviously the mascots there on the right are pulling with a bigger force than the mascots on the left. So the resultant force, there is an overall force in the direction to the right there. Okay, so here's an example of adding forces. If I've got a force of 10 newtons to the right, and if I add it to the force of 10 newtons to the right, I'm going to have a force of 20 newtons to the right. If I have a force of 10 newtons to the left, plus a force of 10 newtons to the left, if I add those together, I've got a force of 20 newtons to the left. And this is the one where it's important to vector. If I have a force of 10 newtons to the right, and then add it to a force of 10 newtons to the left, they will cancel each other out, just like a tug of war where the teams are pulling with the same force. So the resultant force is 0. So adding vectors is not the same as adding numbers. You know, in adding vectors, 10 plus 10 can equal 0 because we have to take into account their directions. And those of you that go on into physics or engineering, vectors are quite important. There's a whole branch of mathematics to do with vector addition and how you multiply vectors and all sorts of things. Okay, it's a bit more, some slightly more complicated examples here. You can see here a force of 6 newtons to the left plus a force of 4 newtons to the right is the equivalent, or the resultant force, if you add them together, is 2 newtons to the left. So when we add two forces together, we get a resultant force. That's the result. If we're going in different directions like this, so 4 newtons in that direction plus 4 newtons in that direction, the resultant force is 5.7 newtons in that direction. You know, if you imagine if you're walking a dog and one dog's pulling you in that direction, one dog's pulling you in that direction, you're going to go in that direction. You're not going to have to do this in the exam, but how did we get that result? Well, we can use Pythagoras, or you can do scale drawing. Yeah, so you know that force plus that force. If I add them together, yeah, so the square root of 4 squared plus 4 squared, it was that 5.7. Or you can use trigonometry. Yeah, you're not going to have to do that, but just so you know where that number 5.7 comes from. Okay, we looked at Newton's law of motion. this is the first one. You won't have to remember this, but you